Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty, my God, for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement for creating these kinds of technical videos. Today's the topic of interest is welding. The welding is a broad area where two metals are going to be joined. If this is a one metal, this is another metal. There is a joining process of these two metals is called as welding. Here we want to know what are the methods to join two components. For joining two components we have three different type. One is temporary join, semi-permanent join and permanent join. In temporary join, bolts, nuts, screws and like the fasteners are come in temporary join. Semi-permanent join, it is something like riveted joints or semi-permanent joints, and permanent join is welding. Permanent joints are weldings. So here the two metals, there is a condition. If two metal may be different or may be same, it can be welded by certain welding process. And also two base metals are same, but the electrode, the metal which we are going to join these two metals may be different, or we can join two parts without any external materials. So like that the welding can be done in different forms, and also it can be done in a solid state or a liquid state or an combination of solid and liquid state. Like that, in different types of states the welding can be done. So here you have to remember one thing. The welding is a first of all welding is a permanent joint, and two materials different or same materials can be joined. Two different or same materials can be joined. There is a several types of welding. Today with my knowledge I'm going to cover the maximum types of a welding which I can know. So I'm going into the topic. First of all, the welding is majorly classified into solid state, liquid state, and solid and liquid state. Where the liquid state, the fusion process is happen, and the liquid state is called as a homogeneous welding, and solid state is called as an autogeneous welding. In solid state, there is no need of any filler materials, whereas the liquid state and liquid and solid state, we need a filler material. If filler material and parent material are same, that is called as a homogeneous, that is liquid welding. If the parent materials are different and filler material is different, then it is called as a heterogeneous welding, that is solid and liquid state welding. This solid state welding, we can explore the solid state welding into cold welding, friction welding, diffusion welding, and forge welding. This cold welding is furtherly classified into pressure welding, explosion welding, ultrasonic welding. Therefore, with these classifications, we can know one thing. By means of an external pressure or an external force only, the solid state materials can be welded. With the help of an external force or an external pressure, the metals are welded. If it is the case, this is called as an autogeneous or solid state welding. Whereas in solid and liquid state welding, that is heterogeneous welding, can be classified into three types. One is soldering, bracing, and adhesive bonding. So adhesive bonding generally done at the brake shoe type of a thing, and the brake pad is pasted in the brake shoe, like the adhesive bonding is being used. There is a paste which is used for joining two materials. In simple case, we can understand that if the two papers if the two papers are joined by means of a glue, it is called as an adhesive bonding. When two pieces of papers, if it is joined by means of any cellophane tape, it is also called as an heterogeneous welding. If these two papers, if it is can be welded by means of another paper, liquidized or fusioned paper, then it is called as an liquid state welding. If two papers can be joined with the pressure, with an external pressure without melting, that is called as an solid state welding. So this is our simple understanding about welding process. And we know that the most of the welding process are liquid state welding process, that is fusion. And this fusion process, the filler material which we are going to use is alike as a parent material or a base material. So here this fusion welding or liquid welding is majorly classified into three types. One is arc welding, chemical reaction welding, and resistance welding. Here the arc welding is furtherly categorized into atomic hydrogen welding, plasma arc welding, submerged arc welding, shielded metal arc welding. In shielded metal arc welding, it can be classified into two types. One is tungsten inert gas welding and metal inert gas welding. And chemical welding is classified into two types. One is gas welding. In gas welding, generally we are using oxyacetylene or hydrogen acetylene. Like that we are using oxyhydrogen or oxyacetylene. Like that the types can be classified further. And next is a thermite welding. In chemical reaction welding, thermite welding is there. In automobiles, most of the automobile components and railway rails are welded by means of a thermite welding process. There uh, iron oxide and aluminum will combine into mixture, and due to the chemical reaction the welding process is done. Next is a resistance welding, single spot welding, multi spot or projection welding, continuous or seam welding. It can be classified, resistance welding can be classified into three types: single spot, multi spot, and continuous. The multi spot, the another name is projection welding, and continuous, the other name is seam welding. So that is all about the types. Here we are going to discuss all the types in detail in this lecture. So it will going to be a lengthy lecture. If you want to know a complete detail about the arc welding or a welding process, you can watch till end. Then you will get a clarity about all the types of a welding process. First, I will go with the arc welding. In arc welding, the arc is generated between anode and cathode. That is, we have a base material, say this is an anode and an electrode is a cathode. Therefore, the electrons are jumped between the anode and cathode with a decent amount of a gap. A spark is ignited, a spark is created. Therefore, both parent metals as well as the electrode will get melted, that is fusioned and joined. So that is the function of an arc welding. Here, the arc is generated between anode and cathode, that is fine. Then, arc is created by means of a resistance between a small distance. Therefore, here we have to understand that arc is generated between the contact resistance. Arc is generated by means of a contact resistance of two the parent and as well as the electrode metals. If the gap is larger, it requires high potential difference. If the gap between the anode and cathode, the gap between anode and cathode is supposed to be a diameter of the electrode or diameter of the rod. So this is our understanding about a simple understanding about arc welding, and we are going to see in detail. Don't worry. And next is a shielded metal arc welding. It is simply called as SMAW. Both AC as well as DC sources can be used. The temperature of an arc is between 6000 degrees Celsius to 7000 degrees Celsius, and these can be, since it is a AC and DC, it can be furtherly classified into short circuit and open circuit type, where in the short circuit no gap between electrode and workpiece. In open circuit there is a gap between workpiece and electrode. And also we have types like automatic and semi-automatic. Automatic is movement of electrode is controlled automatically. Movement of electrode and workpiece is controlled automatically. In semi-automatic, movement of electrode is automatic but relative motion of electrode is manual. So semi-automatic types are MIG welding, metal inert gas welding. We have continuously feed the electrode in the nozzle, whereas the movement of the nozzle can be done manually. And most of the robotic weldings are automatic weldings. It may be MIG or it may be TIG. Those weldings are automatic weldings. Here, I would like to give a brief difference between the tungsten inert gas welding as well as the metal inert gas welding. In tungsten inert gas welding, non-consumable electrodes are used. In MIG, consumable electrodes are used. In TIG, thermal resistance increased by thorium and beryllium. The thermal resistance of the electrode can be increased by thorium and beryllium coating. Here, the electrode feed in form of wires. In tungsten and gas welding, since there is a tungsten is used and both AC as well as DC can be used in TIG, so more heat can be produced. Therefore, the heat affected zone is more for TIG welding, whereas in MIG welding, DC welding is used and consumable electrode, therefore less heat affected zone when compared to TIG. TIG is a slow speed process and MIG is a medium speed process. And in TIG, DC reverse polarity is possible, as well as the MIG DC reverse polarity can be possible. In both the process, DC straight polarity is also possible. And here in TIG, argon and helium are used as an inert gas. As similar to the TIG, in MIG, argon and helium can be used as an inert gas. In TIG process, it is like a heterogeneous, that is, the electrode is a tungsten component and the base parent material may be a different component. The electrode won't melt here, the electron won't melt, whereas parent materials can melt due to the high temperature produced in the tungsten rod. Therefore, it can be said as a heterogeneous, whereas MIG can be said as a homogeneous. In TIG, the major advantage is aluminum can be easily welded, whereas MIG, aluminum cannot be easily welded. The aluminum have a property of high oxidizing property as well as can easily conduct the temperature. Therefore, in any other arc weldings, or another type of weldings, we cannot weld the aluminum, whereas two processes can done. One is friction stir welding or friction welding and another one is a TIG. These two processes, the aluminum can be easily welded, and most of the aerospace and automobile applications, this TIG welding is used. And similarly, the MIG is also used in aerospace as well as the automobile industries. In TIG, design and manufacturing are collaborated. More robotic applications can be done in TIG. Therefore, the electrode movement is difficult and it can be welded at any position, we can say. And in the MIG welding, high initial cost is a major disadvantage. So that is all about the difference between TIG and MIG. Now we are going to discuss an arc welding. As I said earlier, an arc is produced between the anode and cathode. Only DC current is used. There is a small gap between the electrode and workpiece. Most probably, the gap is equal to the diameter of the rod, or sometimes a 3 mm gap can be used. Next is the shielded metal arc welding, that we can also call it as a manual metal arc welding, which all the roadside workshops can be done. These manual metal arc welding or shielded metal arc welding. In gas tungsten arc welding, we are going to see a difference. Gas welding will produce very less amount of heat, and thermite welding can produce 4000 degrees Celsius, arc welding can produce 6500 degrees Celsius. So resistance welding can produce 7000 degrees Celsius. So this is the temperature produced by different welding process in incremental order. Therefore, resistance welding will produce more heat. And we can start with the forge welding. Forge welding is very less temperature is used. That is 1350 degrees Celsius only. At the recrystallization temperature or the above recrystallization temperature, the metals can be applied into the hammer and we can weld. Next, here one thing we have to understand, both AC and DC sources can be used with the drooping characteristics. Drooping characteristics means it is a current versus voltage characteristics. That is, if the terminal voltage reduces, the welding current is increased. So that is the character of the drooping. Next is a temperature between the metals or a anode and cathode is 6000 to 7000 degrees Celsius in arc welding. Here in the electrode we use as flux. What is the purpose of flux is in order to prevent oxidation and arc stabilization and weld pool viscosity control. So these are all the functions of flux used in electrode. And flux coating materials like deoxidizing element like alumina, graphite, manganese manganese, silicon can be used. And for slag formation compound, iron oxide and silicon oxide can be used. For arc stabilizing, Na2O and CaO, TiO, MnO are used. All are oxidized. For welding strength, chromium, tungsten, nickel, cobalt, vanadium can be used for weld strength. And flex coating limitations are the slag inclusions and hydrogen embrittlement. The hydrogen components can be stored between the metal layers, that is called as hydrogen embrittlement. And when the welding is done in multiple passes, then the intermittent slag is being included between the two layers. Next, the open circuit current and closed circuit current. Short circuit current, open circuit current and short circuit current are the two different types where the arc is generated. The first one is the current required during arc generator is the short circuit current, and open circuit current is the current required to maintain gap between workpiece as well as the electrode. So here we have to understand one thing. These two types of the currents, open circuit and short circuit currents, can be used in every welding processes. That is our understanding. If we want to generate an arc, then short circuit current should be needed. If we want to stabilize the arc, open circuit current is needed. Here the equation, the drooping characteristic equation, the V is equal to A plus B into L. Here A and B are constants. V is the voltage, L is the arc length. For the maximum power condition, dP by di is equal to 0, whereas maximum arc voltage condition dP by dV is equal to 0. Here we know that I is the current, V is the voltage, P is the power. For the open circuit voltage, the voltage required is only 80 volts. That is 40 to 80 volts are enough for the open circuit voltage, and this is for the no load condition. The maximum power condition, it can be said to be dP by di is equal to 0. So these conditions are called the drooping characteristics. And for the duty cycle in India, the time used for welding under normal loading condition, which is called as a duty cycle, in worldwide 60% of duty cycles is accepted, that is 10 minutes, whereas in India we accept only 5 minutes of duty cycle. Next is the short circuit voltage. The short circuit voltage is the arc generation during contact between workpiece and electrode. So that is called short circuit voltage. And next is the transformer. In arc welding we have to know the transformer characteristics. The transformer have two types of characteristics. One is a constant current type transformer and a constant voltage type transformer. This constant current type is used in manual arc welding. This constant voltage type transformer is used in automatic as well as the semi-automatic welding. Therefore, in manual metal arc welding, we use open current type transformer. In MIG, TIG like that, we use constant voltage transformer. Whereas the constant current type, which is VI is equal to constant, that is, it is function of the Ohm's law. Therefore, V is inversely proportional to I. Whenever the I increases, V decreases, whereas the V increases, I decreases. So this is the relationship between the voltage and current in terms of open constant current transformer. Whereas the constant voltage transformer, here we have a two types. One is open circuit voltage and short circuit voltage. Therefore, voltage is equal to open circuit voltage minus open circuit voltage divided by short circuit current into I. So this is the formula for finding the voltage of the constant voltage transformer. Here the flat voltage is being used, that is in ampere only the thing. For the stable arc constant voltage transformer, the voltage produced at arc is equal to voltage produced at the transformer. For stable arc, the constant current type, the current required for producing arc is equal to current produced at the transformer. Here we have to know the melting efficiency of a welding process. Welding process is also having the efficiency kind of things. Here the melting efficiency neta is equal to Hm divided by, that is heat required to melt divided by, this is the output heat required to melt. Therefore for required to melt we need a voltage, current, velocity, area and thermal efficiency. So these are all the things. Therefore the Hs, heat supplied is equal to Vi by Va. Therefore efficiency for melting is equal to heat required for melting divided by heat supplied into thermal efficiency. So uh, this is the formula for finding the melting efficiency. The melting efficiency is very much needed, where capital V is the voltage, capital I is the current, and small v is the velocity, A is the area, and neta is the thermal efficiency. Neta T is the thermal efficiency. Hm is the heat required to melt. Hs is the heat supplied. Okay, so that is all about the arc welding process. In the arc welding process, we have a different types of and current can be used both, as I said, both AC as well as the DC, and straight polarity and reverse polarity can be used. Here I would like to give a comparison difference between the electrode polarities. That is, first one, the penetration of DC electrode, DC welding and electrode positive, and next one we are going to compare DC electrode and negative and AC. In DC electrode positive, shallow penetration is there, whereas in DC electrode negative, deep penetration is there. In AC welding, intermittent penetration is there. In heat generation, the workpiece will have one third of the heat generated, and the electrode will produce two-thirds of heat generated. Therefore here the electrode will melt more. Whereas in the deep penetration the workpiece will melt more and electrode will be melt lesser. That is, one third of the heat is generated in the electrode and the two-thirds of heat is generated in the workpiece. In AC, 50-50 percentage. In metal deposition rate, DC electrode positive will have a high deposition rate, electrode negative is have a low deposition rate. Arc welding is have a medium or intermittent deposition rate. The thickness of the work in electrode negative, that is deep penetration, therefore thick sheets can be easily welded, whereas shallow penetration, therefore thin sheets can be welded in electrode positive. In AC, intermittent or medium thickness can be welded. And next, stable small arc. Stable small arc can be easily possible in DC weldings, both electrode positive as well as negative. It is easier, whereas in AC it is difficult. Why it is difficult? We know that the current graph in DC, the current is in the straight line, whereas in the AC there is a frequency Therefore positive negative positive negative. Therefore stabilizing the arc is bit negative or bit difficult. In arc blow, in DC welding, both DC weldings, it is severe arc blow is there, whereas in the AC welding it is insignificant. It is insignificant. Okay. Next, we are going to see the TIG welding process, MIG and TIG welding process. As we know that we have seen earlier the both in detailed comparison of TIG and MIG. I am going to give us some glimpse about the TIG and MIG, and we are going to see some of the different comparison over here, where TIG welding, that is gas tungsten arc welding, GTAW, AC power source can be used for aluminum magnesium alloys and DC power source can be used for rest of the all materials. And we know that this is non-consumable electrode. To increase thermal resistance of the electrode, thorium and beryllium coating is used, and DC straight polarity, DCSP, is used. In DCSP, workpiece is positive and electrode is negative, where DC reverse polarity, the workpiece is negative and the electrode is positive. Yeah. Now only we can see if what happen if the electrode is positive and what happen if the electrode is negative. Therefore, in TIG welding, if it is in DCSP, smooth metal transfer, whereas in the MIG welding, DC RP is used for smooth metal transfer. Whereas if we use the reverse things, that is DC straight polarity in MIG will produce unstable arc and large spatters, whereas in the DC reverse polarity is applied in the TIG welding, more distortion and a larger heat affected zone is being used. Therefore here I will give a detailed comparison of TIG and MIG with DC straight polarity and DC reverse polarity. Therefore, if we want to make a smooth welding, for TIG it is DC straight polarity and for the MIG it is DC reverse polarity is needed. So DC reverse polarity is not good for TIG and the DC straight polarity is not good for MIG. So this is our understanding. Next is a thermite welding. A thermite welding is a very important welding process. Here the collisions is produced. The chemical collisions is being produced. It is a type of a chemical welding process where iron oxide or metal oxide and aluminum powder is in the ratio of iron oxide in 3% and aluminum in 1% is going to combine, and by means of this magnesium wire by means of a magnesium strip, these chemicals can be ignited and it will produce and it will liberate the heat by an endothermic reaction of maximum of 3300 degrees Celsius. Therefore, the 3300 degrees Celsius can be produced by an exothermic reaction. It is an exothermic reaction, that is liberated or heat is delivered, whereas in endothermic reaction the heat should be absorbed, like that. So we have to understand that the difference between the exothermic and endothermic. Exothermic is the heat liberated process, whereas endothermic is a heat absorbed process. Since it is a welding, it should liberate heat, therefore exothermic reaction is the correct one. It is used for welding railway tracks, heavy castings, welding crankshafts, marine applications can be used. The mixture of iron oxide and aluminum is incrucible and melt, and the magnesium ribbon is used to ignite this 3:1 ratio of aluminum oxide and iron oxide materials. Aluminum combined with oxygen, intense heat is produced, and aluminum is act as an reducing agent to and magnesium is used to strengthen the weld, and the heat produced is 242 into 10 power 3 joules per mole of heat can be produced in thermite welding. Next is a submerged arc welding. In submerged arc welding, the deep penetration and high deposition rate is used, and high welding speed, high current, high heat affected zone are being generated in submerged arc welding. Only flat position or downhand position can be welded. No vertical, no top position is being welded in submerged arc welding. This submerged arc welding is a semi-automatic version of shielded metal arc welding. No splatters of molten metals is there. Large diameter of electrode up to 12 millimeter can be used. Granular flux is used, that is powdered form of flux is being used. It can be welded up to 75 mm thickness. That is why it is used for boiler and pressure vessel and shipbuilding applications, that is heavy engineering applications. Generally, iron metal powders are used for melt, and flex material like calcium oxide, calcium ferrite are being used. There is a certain points to remember with these types of a welding process. That is, potassium has a high ionization potential than sodium, and pinch effect is there for the due to the electromagnetic effect. If the pipe carrying gases or liquids, which say gases, it is better to weld. That is why in household application all the cylinders, gas cylinders are being welded. They are not fastened because they are welded because the welding there is no leakage, there is no chance of leakage. So drooping characteristics, manual arc welding, in order to maintain constant current when the arc length changes. So that is the drooping characteristics. In DC reverse polarity, edge welding are being used. Ingredient of the welding functions are silica for the flexing agent, potassium silicate for oxidizing, arc stabilizing, ferrosilicon for deoxidizing, cellulose for gas formation materials. Next, heat affected zone. This heat affected zone, the starting welding temperature. The heat affected zone can be increased by means of increasing welding starting temperature, and if there is high thermal conductivity material is being welded like aluminum, the heat affected zone is more. The heat affected zone leads to stress corrosion, cracking, cold cracking, notch toughness, and hydrogen embrittlement. In arc welding, 65 to 75% of heat is generated at anode, and arc blow is more in DC welding with bare electrodes. That we have to know. And aluminum, we know that aluminum have a poor weldability, high thermal conductivity, high affinity to oxidizing. Therefore, it cannot be welded easily. Only two types of welding can be used for welding aluminum. The coating material should have deoxidizing agent, arc stabilizing agent, slag formation agent. And submerged arc welding is not recommended for high carbon steel, tool steel, aluminum, magnesium, and etc. Arc welding, arc length should be equal to rod length or rod diameter. If we say rod diameter is perfectly good. Arc welding, arc length is equal to rod diameter. We know that cast iron is difficult to weld because of low ductility, high brittleness, poor fusion, tendency to crack on cooling. Therefore, when we want to melt or when we want to weld the cast iron, we should heat treat them. First of all, we have to do heat treatment process and reduce the brittlement. After that we do a welding process. After that we do a heat treatment, and the cast iron original characteristics can be done. For brittle welding, if the weld is said to be more brittle, wrong electrode is being chosen, faulty preheating process, melt and hardened by air. So that are all the chances of making welded joint as brittle. High carbon steel. For welding high carbon steel, both preheating and post heating is necessary. For welding cast iron, preheating is necessary. Liquid state welding process, the fusion zone is there, the heat affected unmelt zone is there, unaffected original zone is there. In liquid state welding, we have a three zones. One is fusion zone, and heat affected unmelt zone, and unaffected original base metal zone. The governing equations of arc welding are these things. One is H by L is equal to E into, E means efficiency into VI by small v, where small v is the welding speed, capital I is the current, capital V is the voltage, small e is the efficiency, capital H is the heat input, and L is the weld length. We know that overall efficiency is equal to melting efficiency into heat transfer efficiency. Therefore, the overall efficiency is equal to SHA divided by VI. That is, S is the speed, H is the heat transfer, A is the area, V is the voltage, I is the current. That we can easily say SHAVI. SHAVI. Therefore, the melting efficiency is equal to SHA by VI into heat treatment efficiency. So that is our understanding about the arc welding process. Next, we are going to discuss atomic hydrogen welding. The atomic hydrogen welding, it is very similar to TIG welding process, where instead of one tungsten in a tungsten electrode, we are using two tungsten electrodes. The heat is produced between these two non-consumable electrodes. Two tungsten bare electrodes are used. Here bare electrode means there is no coating is done. The hydrogen is used as a shielding gas, heating agent, reactive in nature. When hydrogen combines with oxygen, the water vapor is produced and intense heat is also produced. Hydrogen is able to break oxides on the base, therefore, there is no oxidizing is there. Therefore, there is no need of any other inorganic gases like helium and argon in atomic hydrogen welding. The hydrogen will take care of all those things. It forms or produce a clean weld. Therefore, a very good weld can be done in atomic hydrogen welding. The electron travels is not a straight travel like a fan. So electron will not be travel in a straight line, whereas it travels in a like a air in a fan, like that it can be go. The flat position welding only can be produced by means of a atomic hydrogen welding. Since more heat is produced, flat position can only be advised. Hydrogen atoms are formed in downward force. Hydrogen atoms forms a downward force. Since there is a two electrodes are here, the arc is produced here, the hydrogen will make the flow of electron like this. That is the fan's like position. The downward travel like a fan. The applications like very hard tool steels, tungsten, nickel, molybdenum can be welded by means of atomic hydrogen welding. Hard surface weld, repairing of mold dies and tools can be done in atomic hydrogen welding. Next is a plasma arc welding. A huge amount of current is being consumed in this plasma arc welding. It is nearly a 50,000 or in the range of 20,000 to 50,000 range can be produced. Normally plasma arc welding is done at 33,000 degrees Celsius. The temperature produced at plasma arc welding is 33,000 degrees Celsius. You have to notice this. Here, the plasma arc welding, ion gas with current will produce ionized gas with current produce plasma arc. It is similar to TIG, non-consumable electrode is being used, that is hollow, and argon and helium with hydrogen gas is being used. uh, it have a torch like TIG and MIG. The temperature of the plasma is 50,000 degrees Celsius and the range is 20,000 degrees Celsius. These are all the approx values. Keyhole keyhole techniques can be used. Keyhole techniques means very small holes can be welded. Deep penetration is there. The major disadvantage is welding equipment is expensive. Nozzle replacement cost is more. UV radiation and harmful to for skin. There is a huge UV radiation that is very harmful for the skin. Applications like stainless steel, superalloys, precision instruments, aeronautical and jet engines can be welded by means of a plasma arc welding. Next is a stud welding. Stud welding is a faster joining of stud to workpiece, that is called stud welding process, used in machine assemblies. It consists of a gun which is similar to gas metal arc welding. The arc is initiated by means of short circuiting. Next is a fire crack welding, which is very similar to shielded metal arc welding. This is an automatic welding process. It is used in shipbuilding applications. Stick electrode with glass fiber or copper is being used. Arc is initiated by short circuiting and then automatic welding is being occur. Next is a friction welding process. The friction welding process can be done by means of producing a friction between two components. Mostly the drill bit and shank are welded by means of a friction welding process, and most of the aluminum components are welded by means of a friction welding process. In the friction welding process, one part may be stationary and another part may rotate at 3000 or 6000 degree 6000 rpm, or both part can be rotated in opposite direction, and the temperature may be 3000 plus 3000 degrees Celsius, and power required is very minimum, that is only for the rotation only the power is needed. Power required is 25 kVA to 175 kVA, and pressure for low carbon steel is around 40 megapascal, and for alloy steel is 4500 megapascal. Mostly the automobile differentials and hub can be welded using this friction welding process, and duration of the welding is 2 to 30 seconds. It is very shorter welding process. There is no need of edge cleaning. Diffusion method of joining process. It is used in aerospace and as well as the automobile industry. Next, explosive welding process. Very large area and thin plates, thin sheets can be easily welded. Very large area can be easily welded with a finite second. The large area can be easily welded, and massive impact force is used for welding process. It produces detonation. High stress waves are being formed. 1000 megapascal of waves can be formed between the metals. low detonation velocity, that is 2.4 to 3.6 km per second. So with this velocity, the welding can be done. In application like welding of titanium sheets or aluminum sheets, titanium sheet to aluminum sheet can be welded, aluminum to copper sheet can be welded, joining of tubes to tube is easily done. Next is a electron beam welding. The electron beam welding should be done at the vacuum space only, and kinetic energy of electron is converted into heat energy, therefore heat is produced. Here the electromagnetic lens is being used for uh, for making concentrating the electron beam at particular point. The penetration is increased in the vacuum is increased. Vacuum is necessary. When the vacuum decreased, scattering of electrons are there. Therefore, welding is poor. The potential difference is higher would be acceleration of 20 to 200 kilowatt or 30 to 175 kilowatt. The current level is very low, 50 milliamps is used, 50 to 1000 milliamps can be used as a current. The velocity of an electron is 50,000 to 2 lakh meter per second. You can assume that how faster it is being go. Next, the applications are welding of titanium, nickel, stainless steel, aircraft defense, missile, gas turbine pods, space industries are using electron beam welding. The limitations are high initial investment, maintenance cost is high. The next one is an ultrasonic welding. Here the ultrasonic vibration is being used. The static clamping force is being produced between the two pods where dynamic shear stresses are being produced. The plastic deformation is takes place while welding. The transducer is used to convert electrical energy into vibratory, that is mechanical energy. It is a solid state of bonding, no extra sources are needed for heating, and also no filler materials is used. The frequency of the vibration is 20 kilohertz to 60 kilohertz. Thin sheets can be welded less than 1 millimeter. Heat affected zone is very minimum. Heat affected zone is very minimum for ultrasonic welding. Applications like armature welding, electron industries, nuclear reactor components are using this ultrasonic welding. Next is a Protrusion welding process. It is a one type of a resistant welding process used for welding thin wires. Electronic industries, most of the electronic industries are used precaution welding. Next, the very important topic in welding, that is weldability. Weldability means ability of the material to ease of weld, that is called as weldability. The percentage of weldability is equal to resistivity into 100 divided by K resistive constant into T melting point, that is temperature, and K is the heat transfer constants. We know that aluminum have a low weldability and mild steel have a high weldability. If they are asking in increasing in order of weldability, we can start with aluminum, copper, cast iron and mild steel. We know that aluminum is very poor to weld. Mild steel is very easy to weld. That means the weldability is depends upon first the thermal conductivity, surface condition, microstructure and mechanical property. So these are all the properties which the weldability is depends on. Weldability of ferritic stainless steel is used in automotive exhaust system is improved by means of selecting stainless steel electrode to low carbon content. We know that low carbon steel has a high weldability. Therefore, for welding the stainless steel, we use low carbon content stainless steel electrode. Then only the welding is being possible. So with this, I have completed the welding processes which I have know. If you have any doubt, please let me know in the comment section. I'll put a separate video for that. Until, thank you. Thank you all.